Good afternoon, students. I'll start with the class. Today's class will start with definite integration. It is part of integration only. Before that, what we did was indefinite integral. This is definite integral. Indefinite means we used to write plus c. There used to be some constant. Over here, we'll have something called as limits from a to b. Earlier, we used to put this plain integral sign. For definite, there will always be limits. Any function, suppose you're integrating, this is function of x. Anything in terms of x, sin x, maybe x square, x cube, anything, any function in terms of x, we have to integrate. Only extra there will be limits here. So maybe after integrating, you got g of x as the answer, suppose. Usually we used to write plus c. Suppose if this was cos x, the integral of cos x, we would write it as sin x and then plus c. But now here, we will not write it as plus c. We'll have to put a box like this and write these limits here after finding the answer. And then you have to always substitute. So where a is your, I'll tell you, this is a lower limit and this is called as the upper limit. So we have to always substitute the upper limit first. So this will be g of b. Middle sign is always minus. Upper limit minus the lower limit. So this is the formula for definite integration. Any integral you just have to integrate and last put upper limit minus lower limit. So example, suppose first one, I have to integrate x square, suppose, from 1 to 2, from 1 to 2 with dx. Now I have to integrate it as it is. So this will be integral of x square will be x cube upon 3 instead of writing plus c, I have to put a box, write 1 to 2. Now wherever there is x, I have to put the higher limit. So this will be 2 cube upon 3 minus sign, and then wherever there is x, put the lower limit. So 2 cube will be 8. So that will be 8 minus 1 by 3. So answer is 7 by 3. Here there will be no plus c. Next one. You can also do it this way also. Before substituting constants, you can take out also like this. So 1 by 3, this will be 2 cube minus 1 cube. Same it will be 8 minus 1. So that will be 7 by 3. Constants, if you want, you can remove it out before substituting the limits. So integral of x cube will be x raised to 4 upon 4. This will be x raised to 5 upon 5. Now, wherever there is x, put 1. This is using higher limit. Now put a minus sign and now put everywhere the lower limit. First everywhere put 1, then middle sign is minus. So g of b minus g of a. Minus 1 raised to even power is always plus. This will be minus. Raised to odd power is always minus. Now open up this bracket. One by 5 plus 1 by 5, which is 2 by 5. Next one. Two raised to x. Can anyone tell me what is the answer of this integral? What is the integral of 2 raised to x?
Log 2.
2 raised to x into log 2 upon log
X upon
log 2. Yes. It is in the form of a raised to x. So integral of a raised to x is nothing but a raised to x upon log 2. This will be from 0 to 1. And now just substitute. Wherever there is x, you have to put 1. Two raised to 0 is 1. 1 by log 2 is 1. What is integral of 1 upon 1 plus x square or x square plus 1, whichever way? What is integral of 1 upon 1 plus x square? Is there in the formula list? What is integral of 1 upon 1 plus x square? I don't know for what you'll attend the classes if you don't know simple formula. It's there in the formula list. You just have to refer. I'm not even asking you to tell by heart or something. It should be there in the notebook. At least refer that and you can tell me now. What is integral of 1 upon 1 plus x square? The tan inverse of x. Only one person has the formula list. Rest nobody I had given. just put the higher limit. If you just want to attend just for the sake of attending, then there's no point also. You tell your parents that it's waste of time anyway. So tan inverse of -1 is always minus will come out, it will become 1 only. Tan inverse of 1 is 45 degrees, so that is pi by 4, answer will be pi by 2. In which form this is? There's x square and there's a constant term. Which formula to apply? Yes, 1 upon x square minus a square form. So this will be, you have to write it as x square minus a square, then apply the formula. The integral of 1 upon x square minus a square is 1 by 2a log of x minus a upon x plus a. And then, sorry, I did not give you the limits, no? That is 0 to 4. And then put everything 0 to 4. So 1 by 4. You can keep this 4 out also, no problem. Or you can directly substitute. Now wherever there is x, put 4. Then put everywhere 0. This is 2 by 6 log of 1 by 4. You can take out common. There is a modulus sign, no? So -1 also, I can take it as +1. So negative you can take as positive. Modulus sign, so any negative number you get, because log of negative number does not exist. So we have to make it positive. And you know that log a minus log b is log of a upon b. It will be 1 by 4 log of 1 by 3 upon 1. Anyways, it will be 1 by 4 log of 1 by 3. Answer is 1 by 4 log of 1 by 3. Next one. Those who have joined thinking that oh, definite integrals means new topic without studying indefinite integrals, obviously will be lost, because this is not something different from what was done previous. They are same problems, now only with limits it will come. So I told you integration is full continuity, and after that also there's a next chapter coming, differential equations, which is completely based on derivatives and integration. So if you think like no, this chapter I'll skip, I'll follow the next one, not possible. This, which method, what to be done next? The quadratic equation in the denominator. How to solve this? How you would solve this problem? Yes, middle term square upon 4 times first term. The middle term square upon 4 times first term. So this will be, the balancing term is 1 plus 1 minus 1 plus 5. So this will be, till you substitute, write a final answer, these limits will always remain here only. So this will be x plus 1 the whole square plus 4 is the dx. Now this can be written as, now it is in the form of x square plus a square. So you know that 1 upon x square plus a square is 1 by a, tan inverse of x by a. Now since you wrote the final answer, you have to put the limit. Now wherever there is x, put 1. And minus, again put minus 1. Half minus, half tan inverse of 1 it will become, because 2 plus upon 2, and this will be half tan inverse of 0, because 0 upon 2 will be 0. You know that tan of 45 is 1, so this is pi by 4, and tan of 0 is anyway 0. The answer is pi by 8. Next one, pi 0 to pi by 2 sin square x. This is a square of a trigonometric function. Initially in the first class or maybe second only I done this. Whenever a square of a trigonometric function, only integral of this to exist. Integral of sec square x is 10x, and integral of cos x square x is minus cot x. Only this square exists integral if you see in the formula list. But this will not be there in the formula, sine square, cos square, then tan square, and sec, this what is that, cot square. So this you have to try to remove this, express it in this form, 1 minus cos 2x upon 2. because 1 minus cos 2 theta is sin square theta. And if this was cos square, then this would have been plus. All these problems are already done. You can just refer back. Now separate out the integral. 2 I can directly take it out. This 1 by 2 I'll bring it out. Now you just integrate this. Integral of 1 is x. Integral of cos is sine. Now this is 2x. So extra I'll have to divide by 2. So this is 2. If this was simple x, then answer would have been. So whether you write half inside or half outside doesn't matter. Half is always out of the limits also, it doesn't apply. Now substitute pi by 2 first. This you cannot cancel. I'll write first. Instead of x, I'll put pi by 2, then minus, again 0. This half I'll just written in front. 2 and 2, this 2 and 2 will cancel because you are substituting inside. Okay, this 2x, so this x I'm putting as pi by 2, so this will cancel. And sine of 180 is, sine of pi is 0. Again, this is also 0 and sine of 0 is also 0. So what remains is only this. Half into 0 is 0. Answer will be pi by 4. Next one, 0 to pi by 2. This is a simplification of trigonometric functions. 1 minus cos theta is always equals to, minus means sine square theta by 2, and plus means cos square theta by 2, and 2 will cancel. Tan square x by 2. Again, this is a square of a trigonometric function. So I cannot directly integrate square. So I have to convert it into single, or either in terms of sec square, because integral of sec square I know. So tan square theta, you know that 1 plus tan square theta is equal to sec square theta. So tan square theta I can write it as sec square theta minus 1. And integral, you know, integral of sec square theta is tan theta. Now, be careful over here. This is not a single x. There's a coefficient. What is coefficient? So this will be 1 upon half. You have to always divide by the coefficient of x. Coefficient of x is half. And integral of 1 is x. This I have divided because if it was single like this, then answer would have been 10x. But because of this extra half, I have to divide by it. So this fellow will become reverse and go up. Again, I told you, you cannot cancel with the angle. This is outside. This is inside. Whatever it is, you have to write it here up. Never cancel with the angle. So half will go up, become 2. Now substitute the higher limit first. Wherever there is x, put pi by 2. Half I'll just write at the side. Pi by 2. Half into x it is. No? This is wherever there is x, I put pi, higher limit. Then minus wherever there is x, I have to put the lower limit. Higher limit minus the lower limit. So this is pi by 4. This is anyway 0. And 45 is 1. Answer is 2 minus pi by 2. Next one. This type we have done yesterday only, previous class. Whenever there is a e raised to x term, try to think of that formula. Yesterday we had done of the type e raised to x, f of x plus f dash of x. If you have, then answer is always, means function is there and its derivative is there, then answer is f of x plus c. This is of the type which we had seen yesterday. So e raised to x is there, but this I'll have to try to arrange in this form. Numerator, I have to express it in form of denominator. So what I'll do, I need minus 2. So I'll split this minus 4 as minus 2 minus 2. Now separate out. X minus 2. This I'll take as one term. This I'll put separate. One of them will cancel. So we'll have like this. Now we will see if it is fitting in that form. We'll check with what is f of x. Let me take this f of x and see. F of x is, suppose, now I'll try to find a derivative of this. So before finding the derivative, what I'll do, I'll take this on top, raised to minus 2. Now you differentiate. Differentiate means let us find f dash of x. So as per the x raised to n formula, the formula is, the derivative of x raised to n is n x raised to n minus 1. Derivative of x raised to n is n x raised to n minus 1. So as per that, this will become minus 3. Minus 3, if I take to the denominator, it will be, isn't it the same thing here? This is a f of x, and if you find its derivative, this is f dash. This is f of x. This one will be, they will give you the problem only in such a way that one will be f of x, the other one will be f dash of x. So as per the answer, this will be e raised to x 0 to 1. E raised to x f of x. Formula is e raised to x f of x. Now there will be no plus c. Instead you put the limit 0 to 1. And now calculate. Wherever there is x, put 1. E minus 1 the whole square is 1. E raised to 0 is 1. Minus 2 the whole square is 4. Answer will be e minus 1 by 4. Next one. This yesterday only I had done the same problem. This will be written as all half angles. This is 2 sin x by 2 cos x by 2 and 1 plus cos theta is 2 cos square x by 2. And now distribute it to both the places. This problem is already done in the previous class. This will be 1 upon 2 cos square x by 2, 2 sin x by 2 cos x by 2 upon 2 cos square x by 2. 1 upon cos square is x square x by 2, and sine upon cos will give me 10x by 2. So this is in the form of this is f of x. Sorry, this is f of x, and this is f dash of x, because derivative of 10 is x square. So straight away answer will be e raised to x f of x. So pi by 2 upon 2. Don't cancel this, huh? This will reverse and become pi by 4. 10 pi by 4 is 1. The answer is e raised to pi by 2. Next class, the next question.
Excuse me, teacher.
Yes, yes.
Teacher, the question was pi. Was it in terms of pi or x?
0 to pi by 2.
Okay.
Mine, this one problem is my pi always looks like x, like this. I have a habit of writing like that. It is like this, huh? Usually I write like this. Sometimes it may look like x. Limits will not be given. That will always be constants. We'll never have variables as this. What is that? Limit. Always constant. So x will never come on the limit. 0 to 1 x e raised to x dx. If you see now, there are two terms, multiplication of two terms. So you know this is whenever two terms are multiplied, it is u into v. Now just check whether it is in the correct order. I told you L-I-A-T-E. So x means, sorry, in the algebra, and e raised to x is exponential. So it is in the correct order. So no need to shuffle. So straight away this is u and this is v. Now apply the formula. So what was the formula? U into integral of v minus derivative of u into integral of v, and overall again into. How to remember is take the first one and integrate the second. Okay, copy paste as it is the first one, integrate the second. This is always minus. There's a big integral sign. Big means first integral sign. Take the derivative of first one, take the integral of the second one. Whatever answer you get, one final integration. So as for that, this will be x integral of v minus derivative of the first one and integral of the second one. Once you integrate everything, this fine, and one final integration. So this also is 0 to 1, means overall. Okay, left to right like this. Now for definite, after finding everything, this will be overall 0 to 1. Integral of e raised to x is e raised to x only. Derivative of x is 1. Don't put separate, 0 to 1, 0 to 1. Don't do like that. This belongs to the overall answer. This is derivative of x is 1. Integral of e raised to x is e raised to x only. So derivative 1 into e raised to x is e raised to x. So integral of e raised to x is e raised to x. And now wherever there is x, put 1. Wait, this is also there, no? This is with 1. And then minus wherever there is x, put 0. First time, substitute everywhere 1 in the entire problem. Then minus wherever there is x, then put 0. And now calculate. So this will be e raised to 1 is. So that will turn out to be 0. Same thing it is, no? And minus, this is also 0. E raised to 0 is 1. So 1 will be the answer. So minus into minus will give me plus. Now this is a problem. Suppose if the question was straight away 0 to 5 x minus 3 dx. The answer would have been integral of x would be x square by 2 and this would be 3x, and you would solve it this way when it is a simple problem. But now this is a modulus sign. So whenever you have a modulus sign, you cannot directly integrate it, okay? So what we have to do is we have to split the limit in terms of this number. One time, this, suppose if this was 2, then we have to split it from 0 to 2 and 2 to 5. Now the term is this. So we'll have to split it in two parts. 0 to 3, okay? From 0 to 3, you have to take, modulus can take both signs, no? Plus as well as minus. So from 0 to 3, if you try to put any value, just see, any number less than 3 you try to put. Between 0 to 3, suppose if this was 3, I try to put any value here. If I put 0, I'll get minus 3 as the answer. If I put 1 also, I'll get minus 2 as the answer. If I put up till 2.99 also, I'll get minus answer. So that's why I have to use minus sign. And now if you use any number between 3 to 5, you see, put and see. 4 you put, 4 minus 3 will be 1. Okay, 4.5 you put, anything more than 3 you put, even 3.1 if you put, it will always be positive. So from 3 to 5, you will get positive values. You have to split the integral like this. If this was 2 here, then you have to split it from 0 to 2 and then 2 to 5. And now integrate it. So what we can do is first just open up the bracket. So this is minus x plus 3.
Teacher,
Yes.
teacher, in the second step, it is 0 to 3. I mean, in the third one.
Yeah, no. Which 0 to 3 here, no?
Teacher, no, second last. Teacher, before that.
0 to 3 and then 3 to 5. What is the limit given? 0 to 5, no? So I have to split. From here to here, I am getting negative. If this was given as minus 2, I have to take this from minus 2 to 3. So I'm just splitting the limit into two parts. 0 to 3 is the first half and 3 to 5 is the second part.
Okay, teacher.
Now integrate this. So integral of minus x square by 2. This will be 3x. So this one I'll have to put separate limits now. 0 to 3. This will be x square by 2. This will be 3 to 5. Now I solve it. So this will be wherever there is x, you put this. Put a bracket always. And if this is 0 and 0, so it doesn't matter. So this was for this problem. Now plus, again, put 5 first, then minus sign, then put 3. So this is minus is outside, so squaring will not make any difference. 3 square is 9. 9 into minus will give me 9 minus 9 by 2. This is plus 9. This is anyway 0. This is 25 by 2. This is 15. Now be careful of the sign. So this, when you open up the bracket, it will become minus 9 by 2, and minus into minus is plus 9. Now all upon 2 you bring them together. These two common things. So this will be 7 by 2 plus 3. 13 by 2 will be done. Another problem, 11. Suppose x minus 5 dx. I will just this and give split term. Later you can solve same way. Now the splitting term is 5. The middle will come as 5. The first part you have to split from 2 to 5. And there you have to put minus. And then from 5 to 8 you have to put plus. And then solve. Leave some space for that. Just check. I think you should be able to get 9 as the answer. Okay, leave some space for that. Before you can open up the bracket, make this as minus x. This will become plus 5 and then continue. Next one. This is pi by 2. Huh? Always. Our teacher used to follow this, so I have learned writing pi like that one, like this. Zero to pi by 2 cos of x upon 1 plus sin x the whole cube dx. You know that now there's a cos and there's sin and there's so some substitution has to be there. You know that derivative of sin x is cos x. So we have to substitute the function in such a way its derivative whatever comes should be along with there with dx. So what I can do either I can take sin x equals to t, or is the best way is to take 1 plus sin x equals to t. Why? Because we know that even the derivative of 1 will be 0, so it will not matter. So I'll take 1 plus sin x equals to t. So when I differentiate, what will happen is this anyways I'll get 0, and I know that cos x dx will be equals to dt. Now, very important in this, wherever there are limits, whenever you substitute, we have to write integral everything in terms of t. Now these limits which are given are for x. So this is basically means from x goes from 0 to x goes to pi by 2, because we substitute these limits at the end for x term, higher limit where we substitute under x. So these limits are for x. So whenever we are writing the integral in terms of t, these limits should be there for t, not for of the x. So very important, we have to change the limits. So we will see what is the value of t. What was the substitution? 1 plus sin x was equals to t. So we'll see when x is equals to 0, what is the value of t. So whatever is the substitution, this is the main substitution. So put x is equals to 0 here and see. Sin 0 is 0. So when x is equals to 0, t is 1. Now same way, next one, try when x is pi by 2. So this will be, put here pi by 2 and 6. And see. You know that t is 2. So we got the limits. So wherever there is x equals to 0, we have to put t as 1 and this 2. So I write the entire integral now back in terms of t. So with what it will be now when x was 0, what will be t? This will be 1. This will be 2. Now what is the value of cos x dx? This dt. And what was this full thing? 1 plus sin x is nothing but t. This is equals to t. So it will become t cube. Now solve the integral. Now it is there in the denominator. You know that you directly cannot integrate the denominator. So we'll have to bring it up first. Now this is x raised to n formula. So we are integrating it. The limits will go n plus 1 upon n plus 1. Integral of x raised to n is x raised to n plus 1 upon n plus 1. Now solve and then substitute the higher limit and lower limit. So this will be t raised to minus 2 upon minus 2. Bring this down. It will become plus. Now substitute the higher limit. Now wherever there is t, we have to put 2. And then wherever there is t, put 1. Middle sign is always minus. Higher limit minus the lower limit. 1, sorry. This is 1. Wherever there is t, we have to put 1. So this is 4. So minus 1 by 8. Minus into minus is plus 1 by 2. Minus 2 plus 8 by 16. 6 by 16. 3 by 8 will be the answer. Next one. Again, this will be substitution. Similar problem yesterday we had solved with tan inverse of x. We'll take let sin inverse of x equals to t. Now x will be equals to sin t. Sin inverse, if you take on the other side, it will be sin. Now we'll differentiate. So this will be dx. Derivative of sin t is cos t. Now again we have to change the limits because this is given in terms of x. So these are the limits for x. So when x equals to 0, you can take either this or this, whichever one. This value. So put 0 over here or here, first one only can. Main equation. When x is 0, put sine inverse of 0 equals to t. We know that sine inverse of 0 is 0 because sine of 0 is 0. Next is when x is equals to 1 by root 2. So put here sine of which angle will give me 1 by root 2. So we know that sine 45 pi by 4. Now write the entire integral in terms of t. Even the limits are in terms of t now, and even the main problem. So changes instead of 0, what will come now? 0 only. That is not changing. When x is 0, t is also 0. But when x is 1 by root 2, t is pi by 4. Sine inverse of x is nothing but t. This is dt. This is x square. X is what? Sine t. This will be cos square t raised to 3 by 2. One minus cos square theta is sine square theta. So this will be oh dx we have not put no. Wait 1 second. Dx was what? Cos t dt. Just add that up. This was t, but dx was equals to cos t dt. Just check the substitution. Dx value was cos t dt. And this was everything I have jumbled with. 1 second. No one reminds also, they just copy. What was x? X was sine t. So this is sine square t. Just cancel everything and start over all again. Sometimes if you realize something, always this tell me. Sometimes it might be a simple doubt also. It could be my mistake. At least I would be aware of. So this will be 0 to pi by 4 because x was sine t. So this will become sine square t. And dx will be this. So this is cos t dt. This will be cos cube cos square theta raised to 3 by 2. Now this will cancel. Cos cube t or cos t, the whole cube is cos cube t. So one of it will cancel. This will become square. This take it up. So this is t x square t dt. If you notice now there are two terms. This will be u, this will be v. Just check. Liet function. T is algebraic function and x square t is trigonometric function. So it is in the correct order. Apply u into v rule. So u into integral of v minus derivative of, I'm directly writing now. Again, the derivative of u and integral of v. And this overall will be 0 to pi by 4. I have applied u into v rule. So derivative of t with respect to t is anyways 1 only. So t integral of x square t is tan of t. This is dt minus integral of sec square t is tan of t 0 to pi by 4. T tan of t integral of tan x is log of sec of x. And now substitute the limits. Wherever there is t, put pi by 4. This is the first thing. Wherever there is t, I have substituted everything is pi by 4. Now rest just put as 0. So 0 into tan 0 will be anyways 0. Sec of 0 pi by 4. Tan pi by 4 is 1. Sec of pi by 4 is 2. Sec 45 is 2. Sorry, root 2. Because cos 45 is 1 by root 2, no? So sec 45 will be root 2. This is anyways 0. And sec of 0 is 1. And log 1 is 0. So answer is pi by 4 minus log root 2 because this will be 0. Log 1 value is 0. So the answer is pi by 4 upon log root 2. Next one. Next, there are some proofs. Now, one of these proof will usually comes up for exam. Just give me a minute, I'll just get that list of proofs. So this is the list of the proofs. Or again, you have to remember it as a properties also. That's like formula type. You have to remember it like formula also. The first one, a to b f of x dx equals to a to b f of t dt. Second one is third one, 0 to a f of x dx equals to 0 to a f of a minus x dx. Fourth one, a to b f of a plus b minus x dx. The fifth one, a to b f of x is a to c f of x plus c to b f of x dx. Now these five proofs, if they are asked any of these five proofs, then each if it is asked, it will be asked for 2 marks. Okay. Any of this proof, one proof will definitely be asked. If it is asked, it will be asked for 2 marks because they are short ones, small proofs. Or see, either this will be asked or the next list which I am giving, that is only 2 proofs. Out of those 2 can be asked, either this or the next one out of 6th or 7th one. If 6th or 7th is asked, then that would be a 4 mark. But I doubt now this time because the chapter marks have been reduced. So they will not give that 4 marks proof. That's what I'm feeling. But not to take a risk, never know. Because straight away it's worth 4 marks. So sixth one, 0 to 2a f of x dx equals to 0 to a f of x or there are various way of framing this. All have the same proof, but only the question is slightly different the way they frame, but solving part will remain the same. Okay, so this is for 4 marks. If this proof has been asked, then it would be for 4 marks. Or the 7th one, f of x dx equals to 0 if f of x is odd function it is equals to 2 times a to 0 to a if f of x is even function. Minus a to a dx equals to 0 if f of x is odd function and equals to 2 times f of x if it's an even function. This also 4 marks if it comes, or at least 3 marks. This is to be like a common one of this is to come most of the time in the papers for 4 marks. Straight away you could get 4 marks. So we'll start with those 2 marks proofs. Small ones there. First one, what it tries to say is whether you have the letter x or whether you have the letter t or whether you put any other letter, if the limits are same, no, the answer will turn out to be same. So letter doesn't matter. So instead of x, I can simply replace this x letter by t also. I can simply replace this by m also. So what I can put f of m into dm. So letter will not make any difference as long as both are same. So this is property 1. So changing the letter will not make any difference to the answer. So we'll try to prove it. We'll take the left hand side. Maybe after integrating, we got the answer as g of x, suppose, some other function. Integral of f of x may be some other function that is g of x. Now what we'll do, we'll put the limit. We always substitute the higher limit minus lower limit. So as per that, answer will be g of b minus g of a. Then we will take the right hand side now. So consider we had got as g of t now. Substitute the higher limit. So g of b minus g of a. So letter will not make any difference. Finally, answer will remain the same. This is the first proof. If anyone having doubt, you can ask. Second one. what happens is, if you change the limits now, if you reverse the limits, answer will become negative. If you reverse the limit, you can always reverse the limit, but you just change the sign of the integral then. 1 to 2, if I'm writing as 2 to 1, then I have to put minus here. We will prove it. We'll take the left hand side. This is same like the previous problem. You'll get g of x. Maybe integral of f of x is g of x. Then put this. So this will be higher limit minus the lower limit. Right hand side. B to a f of x dx. Now consider this was g of x, b to a. Now higher limit always to be put first, means the upper limit. So it will be minus g of a minus g of b. A always for upper limit always first minus the lower limit. Now open up the bracket. So this will be minus g of a, minus into minus is plus. So just write b first and then a later. So you got left hand side equals to right hand side. Third one, this we'll have to take the right hand side first. Okay, this we'll have to do substitution method. Whatever is inside the bracket, we'll assume it to be t. So when you differentiate, derivative of a will be 0 because it is a constant. This will be derivative of x will be minus 1 dx. So dx will be equals to minus dt. Now, since we are doing substitution, we'll have to change the limits also. To change the limits, so put when x equals to 0, check what is happening. This is your main substitution. So a minus 0 will be t. Therefore, t will be equals to a. When x is equals to 0, t is equals to a. Same way, when x equals to a, put a here, t will be 0. So write the integral now back. The right hand side will be, so this will be a now. Wherever there is x is 0, we have to put t as a. And this will be ulta. This will be f of t. A minus x is t. And dx is nothing but minus dt. Yes.
Teacher, what is that a minus r?
Which one? From where r came?
No, after x is equal to a.
A minus this one you're saying? This one?
Yes.
A minus a, no. Wherever x is a, just put a, no. How we
Okay,
get
teacher.
0? Normal. A minus a, that would be 0. Even if something is wrong with the handwriting, at least try to make out the logic, what it must be. When x is a means I have to put x over here, and then that's why I get t is 0. Now substitute everything in terms of t. Now this minus will come out. So using property 2, what it means, minus, I can utilize and make it reverse. If I'm using minus, so if I'm using this minus inside, I can change. So I'll make this 0 to a and minus, I'll take it. So using property 2, I've reversed. Now using property 1, what I can do, I'm applying property 1 here. I can simply replace t by x. Whether I write t or whether I write x, doesn't matter. And that's why I'll get equals to left hand side. The fourth proof, ulta it is written. Is same as 0 to a, f of, this is a to b. A plus b minus x dx. Take the right hand side. Now same like the previous problem, put a plus b minus x equals to t. Now differentiate. So derivative of a is 0, derivative of b is also 0. This is dx and this will be dt. Now I've differentiated, now I have to change the limits. So put, now when x is equals to 0, put x as 0. Oh, sorry, when x equals to a now, put a over here and calculate the value of t. Here dx is what? Minus dt. In the main equation, put x as a now. When x is equals to b, t will be equals to a. Okay, put b over here and calculate the value of t. So I change the limits also. Now right hand side back. Instead of a, what I have to replace it by? B. So when x was b, what is the value of a? T, it is a. So replace. Now a plus b minus x is nothing but t, and dt is nothing but this dx is nothing but minus dt. Take minus sign out. And then this will reverse. Use property 2. Minus you can use here and change the limits. And then use property 1 here. F of t can be straight away replaced by f of x, which is equals to the left hand side. In the fifth proof, those 4 marks proofs I'll do in the next class. What they are trying to say is this can be splitted into 2 parts. You can take any middle term, and that same you have to continue here. How we are done now for that modulus function, same like that. If I'm splitting this as between as c, you have to take a to c, can separately integrate, and then from c to b. So take the right hand side. Here there is no substitution. Directly we'll integrate. We know that f of x integral is g of x. A to c this will be. And this one will be again g of x only, but this will be from c to b. Now substitute the higher limit minus the lower limit, again the higher limit minus the lower limit. G of C will cancel. Just write G of B first. But it is not still the same. So what we'll do, we'll solve the left hand side also. Left hand side. Integral of f of x is g of x, a to b. Substitute the higher limit minus the lower. It's the same as the right hand. So I'll stop here.